Hi, my name is João Cardoso. I'm a PhD student at the University of Lisbon and a researcher at INSKD. I'd like to present our short paper on machine-actionable data management plans and knowledge retrieval approach to automate the assessment of funders' requirements. In a context where scientific research produces ever-growing quantities of data, researchers are faced with the problem of how to manage their data. So additionally, there's also a growing movement into the increase of the openness of data and adoption of the fair data principles. To cope with both these issues, some funding agencies have now come to require that data management plans be submitted with funding proposals. But what is a data management plan? So in essence, the data management plan, or DMP for short, is a formal document that is used to support data management. So it should describe both the techniques, methods, policies on how data is to be created or collected, documented, accessed, preserved and disseminated, and anything else that pertains to the management of data. The DMP should typically be created at the start of a project, but it should be updated throughout its life cycle, making it a living document. So what's the problem with the current DMPs? Well, mostly they are seen as static documents. They're a text document that is produced at the onset of a project and never looked at again. So it's typically only human readable, not machine actionable, and it's based on a template provided by the funding agency. It's hardly ever published and rarely updated, and it's considered red tape. So what is the machine actionable DMP? And what should it be? Well, it should be both machine and human readable, as the name indicates. It should be shareable, it should comply with a standard, and it should be interoperable. In essence, a living document that is an essential part of data management. Our objective was to look into the funding agency's requirements and explore the possibility of automating their assessment. We set ourselves to explore the application of semantic technology to both express and exploit features of a DMP. In detail, we aimed at formalizing the DMP as an ontology and therefore complying with the machine-actionable DMP concept. Our approach, as can be seen in the screen right now, focused on having researchers creating their DMP based on whatever DMP template is required. However, the end result was to be a DMP that is both machine actionable and compliant with the standard. Our approach can be interpreted in 3 stages. In the first stage, we looked at the application of a common DMP standard. The Research Data Alliance's, RDA for short, DMP Common Standard Working Group has developed the DMP Common Standard Model, which is a minimum set of universal terms that helps in the description of a DMP. We revised this model and proceeded to create the DMP Common Standard Ontology, DCSO for short. The DCSO is represented in OWL, and its model can be seen in the following slide. I'm not going to go into extensive detail over this model that you can see on the screen, because in the end, as you can see in the last slide, it will have to be revised. However, I can point your attention to the QR code on the screen, which points you to the RDA's Common Standards GitHub repository, where you can find all the information regarding the DCSO. In the second stage, we chose a DMP template. We then proceeded to validate if the DCSO would cover the entirety of the DMP template. We came to the conclusion that the DCSO needed to be extended as it would not completely cover the selected DMP template. We then proceeded to create the necessary mappings between the DCSO and the DMP template. In the final step, and given the mappings and the funder's requirements, we proceeded to create description logic queries that would represent the requirements. We then instantiated the DCSO with a real case scenario and performed an automated analysis of the requirements. The real case scenario was based on the genomics unit at the Instituto Gulbenkian Ciência, IGC. In particular, we focused on 2 of their ongoing projects, Genome PT and ONEDA. We created a single DMP covering both projects, as that would allow us to only query one ontology with our DL queries. We then proceeded to create DL queries for both the Horizon 2020 DMP template and the Portuguese FCT guidelines. Then we moved on to assess a number of requirements. The following two slides show two examples of such requirements. We verified if both projects had any costs related to open access. As can be seen, only Genome PT project contemplates costs associated with open access, with ONEDA having no such costs. The second example looks at the researching staff mentioned in the DMP. As can be seen, only one staff element is common to both projects, Susana Ladeiro. This can allow us to infer that this researcher's associated costs must be insured by both projects. So, in conclusion, we attempted to show how DMP expressed as an ontology can have an impact in the assessment of funders' requirements, in particularly by automating that process. We came to the conclusion that the DMP Common Standards model is in need of revision. And our own DCSO is often too generic to adapt to specific DMP templates. It obviously needs to be extended. We are considering using existing frameworks such as the DMP Online and the Data Stewardship Wizard to help us automate the instantiation of the DCSO based on user responses. In essence, there is potential value to be explored here, and in particular in the automated assessment of requirements. But this is future work for us. Thank you for your time.